It's time to export the knowledge. So today we're going to be talking about vectors. So first we're going to have to uh, set some definitions out. So our first definition here is a scalar. So a scalar is a quantity that can be specified by only a magnitude. So what do I mean by that? What I essentially mean is some sort of number. Speed. Speed is a number. I have 20 kilometers per hour. That 20 kilometers per hour, that's the magnitude. If I say travel 2 kilometers, I haven't specified in what direction. So that's where vectors come in. So a vector is a quantity that requires both a magnitude and direction to be fully specified. So I can say go 2 kilometers north. So there's a very particular spot that I am trying to lead you to. Saying 2 kilometers would not necessarily get you to the right spot. So an example would be velocity, right? It's like speed, but it has a direction on it. So now I want to get into drawing a vector. A vector is often drawn as a directed line segment. So what do I mean by that? So you can imagine our XY plane like so, and we have a line coming off it, and we have an arrowhead at the end of it. Something about vectors is it doesn't have to particularly start anywhere. So in this case I've started at the origin, but I could actually start it here and go out and have the arrowhead. And as long as it's the same distance and they're parallel, they would be classified as the same vector. I could also bring it down here. That's the same vector. So it's not one spot to the other necessarily. When we do specify particular points that we want to get to, so let's say point A to point B. I want to get from there to there. I can specify that I want to start at A and finish at B, but that does not mean that the vector that we represent this with is strictly from A to B. For example, a parallelogram, let's say we have C and D, so DC would be the same vector. Now we're going to get into some notation. How do we express A to B? Well, we express it starting with a capital A and a capital B, and then we put an arrow on top of it. And we're saying the vector starting at A, finishing at B. And like I said earlier, this is equivalent to D to C. D, C, and we put the arrow on top. Now, you do not have to write out the full arrowhead in this notation. It is perfectly acceptable to do a harpoon or half arrow. Probably see me doing this more often than that because I think it's quicker to draw and write. So I'm going to have this vector AB, and I want to specify it in a little bit differently. I don't want to continuously write AB with an arrow on it. I want to just quickly write it or assign some sort of values to it. So I can actually write a letter and then I put this little tilde underneath. The tilde is underneath the escape button on most computers. So try and draw that underneath the letter. So when you do that, you're saying that this vector here can be expressed as this vector A, and we can draw it over here, say claiming that this is part of a parallelogram. We can say that that's also vector A. So now we're not specifying a start and end point. We just have the direction and magnitude. So let's say I want the magnitude. What's the magnitude? So the magnitude is expressed as these vertical lines on either side of the vector. So that is the distance. So let's say I start here and I go out here and the distance is 10. And if that's my A vector, then that is equal to 10. So there's one final thing that we need to cover, and that's unit vectors. So if we have the xy plane and I'm going to move a distance of 1 into the positive x direction, that is known as the I unit vector. Similarly, if I go up 1 unit in the positive y direction, I have the unit j vector. And if we want to go into a higher dimension like 3D, there's my z-axis, there's x, there's y. If I move 1 unit up in the z direction, I have the unit vector k. So these unit vectors can be used to express all vectors. So for example, I can go 5 units across, so 5i, and 2 units up. So if we have our xy plane, there's y, there's x. So I've gone 5 units across and 2 units up. So that's where I'll end up, and draw an arrow. And there's the vector, and I can assign this as vector A if I really want to. Which then begs the question, what is the distance then? What's the magnitude? Well, all you have to do to work out the magnitude is think about Pythagoras. We have one side, we have the other side, just square root, and they're squares. So 5 squared is 25, plus 2 squared is 4, which will give me root 29, and that's the distance. That's the magnitude. Similarly, I can work out the angle that it makes with the x-axis with tangent. So tan of theta is going to equal y over x. So in this case, it's going to be 2/5. Now with this unit vector notation here, I can actually add 2 vectors together. If I have 5i plus 2j, and that's my A vector, and I want to add it to 3i minus 2j, and that's my B vector. A vector plus B is going to just be collecting like terms. So we have 5 I units and 3 I units, so that's going to make 8. And then I have 2 minus 2, which gives me 0j. And if we were to look at this, we would go 5 that way and 2 up. So there's vector A. And then vector B, starting from here, I'm going 3 in the x direction, so here, and then I'm going down 2. And what you see is that this is really displacement. I have moved effectively that far. So adding two vectors gives you displacement. Which brings me to my next point. If I have a b vector plus b c vector, because let's say this is a, b, and that's c there. If I go a to b and then b to c, I've effectively traveled from a to c. So I can write that, a to c. That's all we've effectively done. We've displaced. We're using displacement to show as addition of vectors. So I'm allowed to do that. I'm allowed to just cut the b's out and replace it with AC. This only works if the term in between right here are the same. Another thing to keep in mind is AB is not the same as BA. AB could be going this way, but BA, although it's going to be the same length, it's going to be pointing in the opposite direction. So we can say that BA is equal to negative. So that's all. So that's it for this video. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.